What's up, guys? Dylan Codes here, and welcome to day 22 of Advent of Code 2020 in Python. Man, it's crazy. Christmas is in just a couple days here, so time flies when you're having fun and when you're programming. So let's go ahead and get into it. Just a reminder: if you like the video, leave a like down below, and my code will be in a link to GitHub down in the description. So let's get into it. All right, day 22, Crab Combat. It only takes a few hours of sailing to become bored. So we're going to play combat with space cards. Unfortunately, it doesn't take long to teach the crab the rules. So what are the rules? So we have some decks. Okay, the rules are as such. Both players draw their top card, and the player with the higher value card wins the round. The winner keeps both cards, placing them on the bottom of their own deck. If this causes a player to have all of the cards, they win. So once one player runs out of cards, the other player wins. And okay, once the game ends, calculate their score. The bottom card is multiplied by 1, the second from bottom is multiplied by 2, and so on. I see. Okay, so what is the winning player's score? Shouldn't be too bad. Control A, Control C, and paste that in. And let's go ahead and say with open input 22.txt as a file. Now I should just type this in every day before I start the video, because it's the same every time. And data is equal to line.strip for line in data. And now we need to go ahead and parse out what the actual decks are. So if you notice here in the middle, we have this blank line. So I'm going to get the index of that blank line, and then that basically will separate these two blocks of numbers. So we'll just say x is equal to data dot index blank line, and if we print x here, let's see what that is. 26. Perfect. Okay. So deck 1 will consist of all the cards in data for I in range X, so up to line 26, if that line, because we don't want to include this. Okay, and then deck 2 is going to be equal to, make it look nice, data I for I in range, this time x plus 1, because if this is x, we want x plus 1, all the way to the end, length of data, if data I dot is digits. What is wrong with this? And that should be a comma. Okay, so now let's print deck 1 and print deck 2. And let's see, we start with 1, end with 49, start with 44, end with 20. Start with 1, end with 49, start with 44, end with 20. All right, so those decks are correct. Now we are just going to say while length, well, first of all, treat the decks as a queue. So what a queue does, a queue is a first in, first out structure. So the first item in the list is the first item to leave the list. And then when you add an item to the list, it can only be added to the end. So that's exactly how a deck of cards work, especially if you're playing a game like War or Combat in this case. So we're going to say while length of deck 1 is not 0 and length of deck 2 is not equal to 0, because remember, if one of them is 0, then the other player has won the game. And we're just going to say that the card for player 1 is equal to deck 1 dot pop index 0. So what pop is going to do is it is going to remove the card at index 0 from deck 1 and then return it to player 1. And P2 is equal to deck 2 dot pop 0. And then if P1 is greater than P2, player 1 takes both cards. So we're going to say deck 1 dot append. And remember, the winner's card goes first, so P1, and then deck 1 dot append P2. Else if player 2 is greater than player 1, and I guess we will write clean code today. Just this once, some clean code. Deck 2 dot append player 2 1. So we'll append player 2 first, and deck 2 dot append player 1. I think that's pretty much it. So eventually one of the decks will be 0, and we'll say count. Well, so in this case, if length of deck 1 is equal to, if I can type, is equal to 0, then winning deck is equal to deck 2. Else, goodness gracious, can't type for the life of me today. Winning deck is equal to deck 1. And then we'll say count is equal to 0. And for I in range, length of winning deck, then we are going to say count plus equals, and we want to do, so remember, the last item is multiplied by 1. The second to last item is multiplied by 2. So we can take I plus 0, or I plus 1, because we're going to use this I0 to access the last item in the list, but when we access the last item, I is equal to 0, and we want to multiply it by 1. So we could just add 1 each time. I think that works. And then that will access winning deck, length of winning deck, minus 1, minus I. So when I is 0, that'll be the length of the deck, minus 1, which will gives us the actual index for the last one, and then minus 0. So I think that'll work, and then print count. All right, let's go ahead and see what that gives us. Of course, we have an error. What's going on? And I realized critical error here, critical error. We needed to convert the numbers in the cards in our deck to ints. That is kind of like the whole point here. So, you know, let's go ahead and do that. And now if we run it again, 32033. All right, so there's part 1. Now, what do we have in part 2? Part 2, we're going to play a game of recursive combat. So, splitting the cards into 2 decks, same starting decks as before, but the game consists of a series of rounds with a few changes. Before either player deals a card, if there was a previous round in this game that had exactly the same cards, so if we've already seen the arrangement of the decks before, player 1 wins. If this round's cards otherwise the cards are in a new configuration. If both players have at least as many cards in their deck as the value of the card they drew, then the player wins the round by playing a new game of recursive combat, which we'll see below. Otherwise, at least one player must not have enough cards, so the winner of the round is the player with the higher value card. Okay, let's go ahead and start building out our functions, and then we'll look more into these rules. So let's go ahead and reset the deck. So we'll take Control C of our decks from before. In part 2. So there's our decks, and above these two decks, I'm going to write define recursive combat. And that is going to take, so what it will take is deck 1 and deck 2. So it'll take two decks and play a game of recursive combat with them. And then this will just call recursively. And then it will return the string. So this is going to return P1 or P2 depending on who wins. Okay, so now we're going to say here, so prev rounds, so we're going to store each round in this list here. So we just need to store the decks from each round. So we'll say if deck 1, deck 2 in prev rounds, then we can automatically return that player 1 has won this round. Else, so here's the recursive case, prev rounds dot append, and it's going to be a tuple of deck 1, comma deck 2. Okay, so append that, and now we need to handle. So there's a case where we could play determine winner with a sub game, and there's the case where we can determine winner by card value. And so this will happen if if P1, or if the length of P1 is greater than or equal to P1. So if the amount of cards left in the deck is greater than or equal to the card we drew, and length of P2 is greater than or equal to the card that we drew, and this means that we have enough cards to determine the winner of the round recursively. So let's go ahead and pass on that for now. And then otherwise, one of the decks is not long enough for a recursive game. So we'll say else if, it's going to be similar to before, if P1 is greater than P2, then, well, actually here, we forgot to get the cards for the round. So P1, again, is equal to deck1.pop 0, and P2 is equal to deck2.pop 0. Okay, so just to recap here, if we've seen this arrangement of the decks before, player 1 wins. Otherwise, draw 2 cards, and if the length of deck 1 is greater than or equal to the card value, and length of deck 2 is greater than or equal to the card value, then determine the winner of this round with a sub-game. Otherwise, determine the winner by card value. So now, deck1.append, deck1.append player 1, and deck2.append, or my bad, deck1.append P2, else if P2 is greater than P1, deck2.append P1, and deck2.append P1, and this should be a P2. Okie dokie. And before we move on, now if we were just to append these, and then we pop stuff, and then append more stuff, then this will get modified. So to make sure this stays specific, we're going to say .copy on these. Okay, so now we just have to determine that. But before we do that, for the game, we're going to use the same while loop as before. So we'll know the game is over while, yes, we'll say while length of deck1 is not equal to 0 and length of deck2 is not equal to 0. Okay. So because then, so the game ends either if we have an arrangement of decks that has been seen before, or one of the players runs out of cards. So then in the case that someone runs out of cards, okay, if length of deck 1 is 0, then return that player 2 has won, else return that player 1 has won because player 2 ran out of cards. Okay, and then finally, let's determine the winner of a sub-game. So, during a round of recursive combat, players have at least as many cards in their own deck as the number of cards that they have been dealt. The winner of the round is determined by recursing into sub-game. So, for example, if player 1 draws 3 and player 2 draws 7, this happens if player 1 has at least 3 cards and player 2 has at least 7 cards. Okay, to play a game of recursive combat, each player creates a new deck by making a copy of the next cards in their deck, and the quantity of which is equal to the number on the card that they drew. And okay, so if you see here, we're going to start a sub-game. So player 1 draws a 4. So then the length of their new deck in the sub-game is equal to the first 4 cards of their previous deck. And then player 2 has 3 cards in his next deck. Well, I guess it would be these 3 cards. And then I don't think those cards get changed once the sub-game is done. No. Okay. I see. So we're going to do, say, winner is going to be equal to rec combat deck1 dot copy, because remember, we don't want stuff being modified, and then we want everything up to P1 and deck2 dot copy everything up to P2. Okay, and then if winner equals P1, then this is the case. Else winner is P2. Do this. Okay, so that should be our game of recursive combat. And then at the very end, we can count up the count, Control C. Okay, and then we'll say winner is equal to rep combat deck1 and deck 2, and this time we want these 2 decks can be modified. We want these 2 decks to be modified because they are the original decks before we've done any recursion. And then we can say if winner is equal to P1, then winning deck is equal to deck 1. Else winning deck is equal to deck 2, and calculate the score of the winning deck. So let's go ahead and run this. This should be good. And line 48, there's an error. And this should be length of deck 1 and length of deck 2. Okay, now let's go ahead and run it. And it came in about maybe 10 seconds later here, but I have the answer from the recursive solution. So let's go ahead and copy that and put our answer down here. And there's the answer for part 2. So if you liked this video and found it helpful, please drop a like down below, leave any comments, and I'll see you tomorrow for day 23.